Hey guys, Mr. G here. In this video, we're going to take a look at an introduction of unit circle and how we can use a unit circle to evaluate trigonometric functions of a certain degree. So in a unit circle, it lies on a x and y coordinate plane, and the radius is 1. And we see that the center lies on the origin, and then the end point of that radius is somewhere around the circle. So that means that no matter where I move this end point around the circle, my radius is always going to be a 1. All right? So what I want to do is I want to draw an angle that is inside the unit circle. Now, if you guys recall from the previous lesson, we talked about angles in an x and y coordinate plane. Now, we refer to that as angle in standard position. All right, so the angle in an x and y coordinate plane has two parts. Now, the first one, which is the first right, is the initial position, meaning the starting position of the angle. And then we have the second part of the angle, which represents the terminal side. So I'm going to draw a line from the center to anywhere on the circle. All right. So this represents the terminal side. Remember, this is the initial side of the angle, and then this is the terminal side of the angle. And then with the angle, we always have the angle measurement, which is represented as theta. All right. So now we have our angle measurement, and what I'm gonna do is I'm gonna create a right triangle by drawing a line going down from this point. All right. And when we draw the line down, this line is perpendicular to the initial side of the angle, which creates a right angle. All right, so I have my right triangle over here. All right, so we have our right triangle inside the unit circle. So what was the purpose of drawing a right triangle inside the unit circle? Well, we can use that to help us evaluate trig functions, meaning sine, cosines, and tangents of a certain angle measurement in a unit circle. All right, now before I do that, let's go ahead and label more pieces of information in this unit circle. Now, if you recall, the radius in a unit circle is 1. So if we take a look from this point to this point, that's the radius. So that means that this would be 1 unit. All right. And then we have this point, which is the intersecting point of the terminal side and the circle. So this one is a specific coordinate, a specific x and y coordinate. All right. So now what I can do is I can try to label these two sides those two sides of the triangle as x and y, and there's a reason for that. If we take a look at this side, the base of this triangle, we see that is on the x-axis, and is going in an x direction. So I can label this one as x, where over here, we see that it's going on a vertical direction. We see that if I were to move up, it would be a y direction. So that means that this would represent my y value, all right? So we have x, we have y, and we have 1, and 1 is looking like the hypotenuse since it's opposite to a 90-degree angle, and hypotenuse of a right triangle is always opposite to a 90-degree angle. All right, so what I can do now is I could write trigonometric ratios for this specific right triangle. So I'm going to write trig ratios for this right triangle with sine, cosine, and tangent. all right? However, I'm gonna start off with cosine instead of sine. And there's a reason for that. So let's start off with cosine of theta. So let me write it over here. Actually, let me write over here. So I have cosine of theta. Now, cosine of theta, if you recall, the ratio for that would be the adjacent side over the hypotenuse. Now we need to figure out we need to figure out which of the sides in this right triangle represents the adjacent and which of the sides in this triangle represents the hypotenuse. As I stated earlier, the one represents the hypotenuse. So I'm going to label, so one represents the hypotenuse, so I'm labeling as hypotenuse. It's going to be a little bit small. All right, and then we have x and y left to figure out which of the sides represent the adjacent. Now the adjacent would be the side that's closest to the angle measurement, which in this case is x. So x is going to be my adjacent. All right, so that means my adjacent would be x over my hypotenuse, which is 1 in this case. And if I were to simplify x over 1, I'm just left with x. So cosine of theta equals to x. All right? So now that I did cosine, I'm going to go ahead and do sine of theta. So I have sine of theta. So I'm going to label cosine and it equals 2x. So now I have sine of theta. Now sine of theta, if we recall, the ratio for that is the opposite over hypotenuse. So we got to figure out which side represents the opposite and which side represents the hypotenuse. Since x was already labeled as adjacent, that leaves y to be the opposite. So y represents the opposite and x represents the adjacent. So for my ratio for sine, it would be y over 1. And if I were to simplify this, it would just be y. So sine of theta equals to y. So cosine of theta equals to x, sine of theta equals to y. All right, now we're left with tan of theta. Now I'm going to do tan of theta over in this space. So we have tan of theta, which is the opposite over adjacent. All right. So we already labeled which side is opposite and which side is adjacent. And the opposite is y. If the adjacent is x. So tan of theta equals to y over x. So we were able to figure out, we were able to write out the three trigonometric ratios for this right triangle inside a unit circle. And we can confirm that these three outcomes are set formulas when evaluating sine, cosine, and tangent of an angle measurement inside the unit circle. So if we were to take a look, we see we have this x and y coordinate, which is the intersection of the terminal side and the unit circle. So what I can do is I can substitute x and y, x as cosine of theta. Since this equals to x, I can substitute x as cosine of theta. And then I can substitute y as sine of theta. All right? Since sine of theta equals to y. So we have, we have x comma y could be substituted as cosine theta comma sine theta. So that means that when I'm evaluating cosine of a certain angle measurement, that's just going to be the x coordinate of the intersection between the terminal side and the unit circle. And same thing for my y value. Same thing for sine of theta. It's just going to be the y value of that intersecting point. All right? So what we're gonna do is we're gonna take this concept and figure out X and Y coordinates for just certain degrees, all right? Starting with a 30 degree. So for the first one, we're gonna find cosine and sine of 30 degrees, all right? So what I'm gonna do is I'm gonna draw an angle measure. I'm gonna draw an angle in standard position. So I have my terminal side and I have my initial side. All right, so this represents a 30-degree angle measurement. All right, so now what I can do is draw my line going down, and it creates a right angle. All right, so we created a right triangle inside the unit circle. All right, and if we take a look, we see that we have a radius from the center to the end point of a circle, which is always 1 unit. So I'm gonna label this side as 1. And we do have an intersecting point, but we don't know what that is, since we're actually given an angle measurement. So what I wanna do is I wanna figure out what is my X and Y coordinate when theta equals to 30. Okay, so what we can do is we could use the technique of special right triangles that you guys already done and apply it to figure out the X and Y coordinate for 30 degrees. All right, so we have this side, which represents the X value, and this side, which represents the Y value. Now we have a right triangle, we have 30, 90, and remember, a special right triangle has angle measurements 30, blank, 90, and that blank would represent 60 degrees. All right, so we have a 30, 60, 90 degree triangle, and luckily with that, 2 out of the 3 sides have specific formulas. All right, I'm gonna put them on the side. So this is the formulas for each side for a 30, 60, 90 degree angle, starting with the short leg. Now the short leg is on the opposite side of 30 degrees, the smallest angle. And if you take a look, we see that the short leg is on the same position as the Y value over here. So whatever the measurement for my short leg is going to be my Y value over here. And then we have the long leg, which in this case is the base. And that is always opposite to the 60 degree angle measurement. And in that one, we take the short leg and multiply by √3. So after I figure out my short leg, I just multiply whatever value for that short leg by √3, and I get my measurement for the long leg. And then we have the hypotenuse, which is 2 times whatever the value of the short leg is equals hypotenuse. And if we take a look, we actually have a measurement already, which is 1. So what we can do is we can make 2 times the short leg equal to 1. Now we gotta ask ourselves this: 2 times what gives me 1? So that means that we gotta think 2 times what number gives me 1? How do we go from 2 to 1? Now, if you guys said half, then you're absolutely right. If you guys are still not sure how we get that, what you can do is you can make 2s equal to 1 and divide both sides by 2. So that way, your short leg, s, would equal to 1/2. So that means s, which is on the vertical side, equals to 1. So that means that this represents 1/2. Since this side is opposite to the 30 degree angle measurement. And this is on the same spot as my y direction. So we have my value for y, which is a 1/2. All right. So now that I have my value for the short leg, I can go ahead and multiply this 1/2 by √3. So I have 1/2 times root 3. And all you need to do is just multiply the 1 and the root 3, and then you should get root 3 over 2. So then that's going to represent the long leg, which is on the x direction. So my x value for this one would be root 3 over 2. Now this is going to be my x and y coordinate for a 30-degree angle measurement. All right? This is the x and y coordinate for the 30-degree angle measurement. All right? Since the initial side and the terminal side make up that 30-degree angle measurement. So now we can go ahead and find the cosine and sine for 30 degrees, starting with the cosine. All right, so we have cosine of 30 degrees. And if we recall, if I were to flip this paper back, we said that cosine of theta, whatever angle measurement we're working with, in this case is 30, equals to x, my x coordinate. Excuse me. And if we take a look, my x coordinate for this point is root 3 over 2. All right, so cosine of 30 would be root 3 over 2. And then we have sine of 30 degrees. And sine of 30 degrees is my y value. And my y value for this one is 1/2. All right? So we have cosine and we have sine. We evaluated cosine of 30 degrees and we evaluated sine of 30 degrees. Now, I'm going to do the tan of 30 degrees later on. But all I wanted to do was do cosine and sine since they were just the x and y value of this angle measurement. All right? Remember, when my angle measurement is 30 degrees, my x and y coordinate is root 3 over 2, comma 1/2. So for 30 degrees, this is my x and y coordinate. All right? So now we're going to find the cosine and sine of 60 degrees. All right? Since we're still working with the 30, 60, 90 degree angle, let's go ahead and try 60. So we're going to find cosine and sine of a 60 degree angle measurement. All right? So I'm going to draw a right triangle. Well, before that, I'm going to draw my angle measurement with my terminal side and my initial side. So let me draw my initial side first. So I have my initial side, which is always on the right side of the x-axis. And then I have my terminal side, which is like pretty close to 90 to the top part of the y-axis. All right? So now I'm just going to draw a line down. So I have 60 degrees over here. I have my right angle. And since we have 60 and 90, this would be left as a 30. So we have a 30, 60, 90 degree angle. But the angle that I'm focusing at is 60 degrees. We just need 30 degrees just to figure out the measurements over here. And we have my intersecting point from the terminal side to the end of the circle. All right. Now, from the previous unit circle, we worked with the 30, 60, 90 degrees. And if we take a look, we see that we have a radius, which is from the center of the triangle, center of the circle, which is the origin, to the end point of the circle, which is 1. So remember, my measurement for a radius is 1. All right? So now we need to figure out the other two measurements. Now, we have a 30, 60, 90 degree triangle, which we could use this formula again. But what if I said that we don't actually have to do much work for this one? We could actually use the numbers and the work from the previous example to help us figure out the missing sides and then put my x and y and figure out my x and y values. So if we were to compare these two, we see that we have basically two of the same triangles with the same hypotenuse. So if the hypotenuse for the two triangles are the same, then it means that my sides for these two are the same thing as well. They're just going to be reversed. And if you take a look, we see that from this example, we had 1/2, which is the opposite side of 30 degrees. So that means that whichever side is opposite to 30 degrees is going to be 1/2. And if we take a look between these two sides, this one is away from 30 degrees. So then this side represents the half. Now, if you guys aren't sure how I'm getting this is the same exact technique of using the 30, 60, 90 degree triangle, where my hypotenuse is still 1, and to figure out the short leg, I can just take my hypotenuse, 2 times the short leg, 2s, and make it equal to 1. And 2 times a half equals to 1. And that half is always opposite of 30, which in this case is up here. So we have this side, which is opposite of 30, is going to be half. So then we have 60 degrees. And if we take a look, if we recall, 60 degrees is opposite to √3/2. So this is going to be √3/2. So that means that my x value is 1/2, and my y value is √3/2. So this is going to be my x and y coordinate for a 60-degree angle measurement. All right. So we have our x and y coordinate set stone for a 60-degree angle measurement. So we can find the cosine and sine of 60 degrees. So let's start off with the cosine. So we have cosine of 60 degrees, which equals to my x value. And my x value for this point is 1/2. All right. So then we have sine of 60 degrees. Now that is going to represent my y value. So in this case, we have √3/2. So my y value is √3/2. √3/2. So we have our two outputs for cosine and sine. Okay. We're going to use another special right triangle, which is a 45, 45, 90 degree. So I need to figure out cosine and sine for a 45-degree angle measurement. So I'm going to go ahead and draw my angle with the initial side and my terminal side, which is kind of like right over here. It's kind of like in the middle. All right. So we have 45-degree angle measurement, and I draw my line going down to make a right triangle. And then this would be the 90-degree angle measurement. So now what I can do is figure out my x and y coordinate for this intersecting point by using the 45, 45, 90-degree angle triangle rule, which luckily isn't that. It actually requires less amount of work than the 30, 60, 90-degree one. All right. So just like the other two examples, I have a radius going from the center at the origin to the end point of the circle, and the radius is always 1, which again is a hypotenuse. All right, so we have a 45, 45, 90-degree angle. So luckily these two angles are the same. So if two angles on a triangle are the same, then the two sides have to be the same as well. So we know that this side and this side are going to be the same number. So that means that this side and this side are going to be the same x and y values. All right? Now, if you recall, we have a formula for a 45, 45, 90-degree triangle, which I'm going to draw over here. So I'm going to draw the right triangle for 45, 45, 90-degree right triangle. All right? So we have the short sides, and then a hypotenuse, you just take the short side and multiply it by root 2. All right? So all we need to do is just figure out what did I multiply to root 2 to give me 1? So this isn't going to be an easy guess and check kind of situation like the previous examples. I'm actually going to have to do some math for this one, which I'm going to do on the side. So what I'm going to do is to figure out the hypotenuse for 1, I'm going to take 1 and make it equal to s times root 2. So I have that, and all I need to do is just divide both sides by root 2. So then my answer for s would be 1 over root 2. But that's not the case, because if we take a look, we have a tenth in the basement, radical in the denominator, and we're supposed to have no tenths in the basement. All right, so all I need to do is rationalize by multiplying both numerator and denominator by root 2. So then my final answer for the side is going to be root 2 over 2. So that means that my side for the right triangle over here is going to be root 2 over 2. So this is root 2 over 2, and over here is root 2 over 2. So that means that my x and y values are the same number. So I can write it as root 2 over 2, root 2 over 2. So this is my x and y coordinate for a 45-degree angle measurement. All right? So now I can figure out and evaluate cosine and sine of a 45-degree angle measurement. So let's go ahead and do that. So we have cosine of 45 degrees. So cosine of 45 degrees equals to the x value, which in this case is root 2 over 2. And the same thing for sine of 45 degrees, which equals to the y value, and luckily it's the same exact number. So I have root 2 over 2. So I have my two answers for cosine and sine. So before I concluded the video, I definitely want to talk one more thing about the unit circle, specifically the quadrantal angle measurements, meaning the angle measurements that are divisible by 90. Now we have 4 points that are on the axis. We have this point, which represents starting with 0, this point, which goes to 90, this point, which is 180, the next one, which is 270, and then the last one, which is 360, which is on the same spot as 0. So what I want to do is I want to talk about what are the x and y coordinates for these four points. All right, starting with 0, 360. Now, earlier we talked about the unit circle having a radius of 1 unit, and the radius has to start from the origin to the end of the circle, and is going 1 unit. So if you take a look, we see that this is going on a horizontal direction. So that means that we're going 1 unit horizontally across the x-axis. So that means that this point would be 1, 0. That means that I'm moving 1 unit to the right and 0 units vertically. All right. So then I move my radius counterclockwise and I land at 90 degrees. So if you take a look, from the origin to 90 degrees, we're going 1 unit up, which represents the y direction. Since we're going 1 unit up, my coordinates would be 0, comma, positive 1. We're going 0 units horizontally, but we are moving 1 unit up. All right? And then let's say we're going counterclockwise to 180. So from the origin to 180, we're moving 1 unit to the left. So if we're moving 1 unit to the left, that means we're going in a negative direction horizontally. So that means that this point would be -1, comma, 0. All right? And then we have 270, which from the origin to this point, we're going 1 unit down. So that coordinate would be 0, comma, -1. Since we're going 1 unit down, it's going to be a negative direction. And then we get to 360, and we're back in the same spot as 0 degrees, which is 1, comma, 0. So we have these 4 coordinates. And then if you recall earlier, we discussed how x, comma, y could be substituted as cosine of theta, comma, sine theta. So let's say I'm evaluating cosine of 360 degrees. All I need to do is look at the x coordinate from at that point to evaluate it as cosine. And we take a look, we see that it's 1. So cosine of 0 degrees is 1. And same thing with if I were to do cosine of 360. Cosine of 360 would be 1. Now if I were to ask about the sine of 90 degrees, we see that my y, all I have to do is just look at the y value, which in this case is 1. So sine of 90 degrees would be 1. And so on with other degrees that we're looking at. All we just need to do is look at the x or y coordinate to evaluate cosine of theta or sine of theta. If you guys still have any other questions, feel free to email me. Hope you guys have a wonderful day.